So let's go ahead. We're going to ignore the first part of the notes for now that says solution of a system of inequalities. We're going to start just with these example problems. So before Friday, last week, we were graphing inequalities, and we just graphed one at a time. And so today we're going to be graphing two at a time. Right, Chris? Let's put the phone away. Thank you. So we've got this first one. It says negative 1/3 x minus 2. What should we start with? The negative 2. And then from there, where should we go?
Down 1 to the right 3.
Down 1 to the right 3. Down 1 to the right 3. Okay. And then what should we do if we run out of space? Go up and to the left. So go up 1 to the left 3. Go up 1 to the left 3. Okay. Is this a dotted line or a solid line? Solid. Okay. And then from there, we have to decide if we should be what side of the line we should be shading on, right? Because this is an inequality, and inequalities always require some shading. So what point would you guys like to plug in to figure out the shading? And Lily, let's go ahead and get out of our email and take notes. So 0, 0 is a great point to plug in. So there's 0, 0 right there. So I'll go ahead and plug it in over here. So I've got 0 for x and 0 for y. So 0 is greater than or equal to negative 1/3 times 0 minus 2. Anything times 0 is what? 0. So we've got 0 is greater than or equal to negative 2. Is it true that 0 is bigger than a negative number? That's true. Okay, so this is where the stuff is true. If the stuff is true over here, the point is true over here, that means it's false over here. And then where do I shade? I shade where it's true. Okay. All right, for the other line, what do I do?
You go to 3.
Go to 3. This one for the slope just has a negative 2, so how do I make that a fraction? Yeah, I put it over 1, and then it's a negative slope, so what should I do? I should go down. So I'm going to go down 1, 2 to the right 1, down 1, 2 to the right 1, down 1, 2 to the right 1. Okay. And based on the symbol, is this a dotted line or a solid line? This is a dotted line. Okay. Yeah, I'm doing a different color because I'm pretending that I can't even see the pencil at all. I'm just focusing on my blue right now, or whatever color you have. I'm just focusing on that. So would you guys like to use 0, 0, or would you like to use a different point? 0, 0 again? Okay. So again, I'm pretending that I can't see the pencil. I'm just looking at the blue. So this time 0, 0 is on the left side of the line, and then we're comparing that to the right side of the line. So I'm going to use 0 for x and 0 for y. So we've got 0 is less than negative 2 times 0 plus 3. So 0 is less than, anything times 0 is 0. This says plus 3 on the end, yeah. So that's 0 plus 3, which is just 3. Is it true? She didn't have permission. So feel free to do with that what you need to. So 0 plus 3 is... Anybody? It's true. 0, so 0 plus 3 was 3, and this is true. So this point right here is true. And then what does that make this side over here? False. So where do we shade?
You have to write true or false every time.
You do not have to if you don't feel like you need to. Okay, so we shade where it's true. So we're going to shade over here. Okay, so now this brings us to what is the solution to a system of inequalities. Okay, so on Friday, we were learning what's the solution to a system of equations. So a system of equations was two lines, and if you have two lines, then when they cross, you get just 1 point. Where two lines cross, you get 1 point. That 1 point is the answer. When you have inequalities, they don't just cross at 1 point and have that 1 point be the answer. They have two places where the shading crosses. So we've got the pencil shading and we've got the marker shading, and that crosses for a whole area. And this whole area is the answer. So there's not just 1 point that's the answer, there's tons of points that are the answer. So I would say like this is an answer, and then this is an answer,
So we just write any other
and this is an answer, and this is an answer, and this is an answer, and so is this, and so is this, and so is this. In fact, it's not just the points that are on the corners, it's actually the decimals in between. Because any point that's in between is still a point, it just has decimals for the coordinates. So those actually still work. Yeah, decimal answers matter too. So what I'm going to do is I'm going to make this part right here really dark. Once I've graphed both of my inequalities and I can see where the two colors cross each other, I always go back and I make it really dark so that I can tell where that double shaded region is. That's what I call it, the double shaded region. And then the solution to a system of inequalities is the double shaded region where the two sets of inequalities cross. Now, you'll know you did a good job of double shading if somebody could see your solution across the room. Can everybody see my solution when I hold it up? You can see it across the room? That means I did a good job of double shading. Okay, so we're going to write the answer up here. So the solution to a set of inequalities, a system of inequalities, we're going to say is two or more inequalities where the two or more inequalities where the shaded regions and solid lines are intersecting. So a dotted line does not represent solutions. A solid line does. So if we look at this graph right here, this point where the lines cross is not a solution because it's a dotted line and a solid line crossing. Dotted lines are not solutions. So our solutions show up in the double shaded region, and they show up on the solid line right here. So that's where all the solutions are. So 0, 0 is a solution to the system. -3, +4 is a solution to the system. -8, +8 is a solution to the system. Any point in the double shaded area, those are all solutions to the system. Okay? All right, let's try the next example. So this one has equations that need to be rewritten so we can graph them. So I'm going to write it's positive. Positive 2x plus y equals -3. 2x plus y equals -3. And then what do we have to do so that we can graph this? Subtract the 2x over to the other side. Y equals, we write the x first. So y equals the -2x and then the -3. Okay, so where do we start? -3. And where do we go from there? Down to right 1. Okay, down to right 1. Down to right 1. I ran out of space, so what should I do? Up to left 1. Up to left 1. Okay. And based on the symbol, is this a dotted line or a solid line? Solid line. Okay. And what point do you guys want to plug in? 0, 0? Okay. So 0 for x, 0 for y, 0, 0 is right here. So we have 2 times 0 plus 0 is greater than or equal to -3. So over here, that's 0 and 0, so all of that zeroes out. We get 0 is greater than or equal to a negative number. True. So this is the true side. This is the false side. So where should I shade? Where it's true. Okay. All right, for the other line, I have -x plus y equals 0. And what should I do? Say that again? Make the x positive. I want to move it to the side without the y. So I've got my y all alone. And then which of these should I write first? The x. So I've got a positive x, and then I'm going to put the 0. What number is in front of the x? A 1. How do I write a 1 as a fraction? Put it over a 1. Okay. So let me get my marker out. So where should I start that graph? At 0. And then where should I go from there? Up 1, right 1, up 1, right 1, up 1, right 1. Okay, and I'll go the opposite way as well. Based on the symbol, Is that a dotted line or a solid line? It's a dotted line. Okay. Now, if we look at the line, can we plug in 0, 0 this time? No, because it's on the line. We have to pick a point that's on a specific side so we know if that side is true or false. So we're going to have to pick a different point. We could do 1, -1. 1, -1 would work. So 1, -1 is right here. 1, -1. 1 for x, -1 for y. So it would be negative and then 1 for x plus -1 for y is less than 0. And we get -1 plus -1. What is that? -1 plus -1. Wait, -1 plus -1. It's 2 negatives, which is it's -2. So -1 plus -1. And if you're not sure about that, you can just type it in your calculator. So the way that we read it out loud, we read it as -1. So we're going to type -1 plus -1. -1 plus -1 is -2. What if you what? You can just grab a different color and shade it differently. Yeah. All right. So if this is -2 is less than 0, is that true or false? Wait, -2 is less than 0? Negative is less than 0? That's true. That's true. Okay. True over here. False over there. Okay, so here's our shading. We shade toward what's true. Okay. And then we're going to go back and get our double shade. Make it nice and dark. Okay, and here is where your Chromebooks are going to come in. So I want everyone to be on Desmos. So go ahead and, yep, Desmos.com. Go ahead and get on Desmos. Desmos.com. So Desmos will graph these for you, and it will do all the shading, and it will do the dotted lines, and it will do the solid lines. So we're going to go ahead first, and we're going to graph the first example. So y is greater than or equal to. And so to do the greater than sign, you're going to do the key that's right next to the question mark, and you have to do shift. So we're going to do y. And you're going to do shift, the key that's right next to the question mark. And then to get it to say y is greater than or equal to, you actually have to press the equal to key next. So that's next to the backspace. And if you press the equal to key next, it will slip the equal sign right underneath that greater than. So I'm going to press the equal button, and it just slipped the equal to sign right next to that. Not until we're done. All right, so y is greater than or equal to. Everyone type in that. Y is greater than or equal to. Now I'm going to do -1 divided by 3. And then I'm getting my x
Is this
minus
just
2.
behind ourselves?
Huh?
Is this just to check?
Yep.
Can I go to the next box?
How do we what? So we typed in the greater than, which is next to the question mark,
Or they can,
and then the equal to, which is next to the backspace.
how I get the greater than sign is I use a little keyboard thing.
You can do that too. And then y is less than negative 2x plus 3, and you'll see it does the dotted line for you. And if you want to double check and make sure they still cross at the same point that yours cross at, you can double check. They still cross at 3, negative 3 like ours do. It's not a solution, but they cross there. All right. So we checked that one. Now, this is not how I want you to graph them from start to finish, but this is a good way to check our answers. Do you guys know how to use Desmos to see what the points are on your line? Have you guys ever used Desmos to see the points on your line? So if we want to know what the points are on the first line, we just go back and have the cursor on the first line, and then we press the gear up here. And, oh, it doesn't do it for inequalities. Just kidding. So you'd have to type it as an equation. Go back, get rid of that, press the equal sign, press the gear up here, and then press table. And then it will give you actual points that you can graph. I don't recognize it either. I was going to say it almost looks like no, you're in class. So if you put the cursor after the 2 and press enter a bunch of times, it will give you more points. Unfortunately, it does not do that in the negative direction. So to get more points in the negative direction, you actually have to type in the negatives. But in the positive direction, at least, it will give you all the positive numbers. And then you can kind of see what the points are. Okay, let's double check our second example and make sure we graphed it correctly. So for the second one, we've got 2x plus y is greater than or equal to negative 3. So there's that first one. And then negative x plus y is less than 0. And that looks like our graph. Crosses at negative 1. Negative 1. Yep, that looks like our graph. So just always a good thing to use Desmos to check your answers on these and make sure they're right. Okay, so these are pretty easy to make a mistake on. So should you be using this to do the work? No, but this is a great way to check yourself. Okay? You're welcome. Okay, let's try the next one. All right, so 5x plus y is less than 2. So first I'm going to take my equation. I want to be able to graph it. So what should I do so that I can graph it? Subtract the 5x. I need to move the x over to the other side. And then the y is all alone. And then which of these should I write first? Negative 5x plus 2. Okay. And then how should I graph this? Start at 2. Put it over 1, so it's a fraction. Okay. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And then if we look back at the problem, based on the symbol, is this a dotted line or a solid line? Dotted. Okay. What point would you guys like to plug in? 1, 1. So 1, 1 is right here. So 1 for x, 1 for y. Five times 1 plus 1 is less than 2. Five plus 1 is 5, plus 1 is 6. 6 is less than 2. False. So if this side is false, the other side is true. So where should we shade? The true side, shade left. Okay. Where do we start on the next one? -5. I'm going to write my slope as a fraction. How do I do that? Put it over 1. Okay, so from the dot, what am I going to do? Up 2 over 1. Up 2 over 1. Up 2 over 1. Is this line solid or dotted? Solid. Okay. And then what point do you guys want to plug in? 1, 1? So 1 for x, 1 for y. And you don't have to plug the numbers in your head. You can always plug them in on a calculator and just type it in exactly the way it looks. So is it true that 1 is bigger than -3? Yes, that is true. So the point is true. So I'm thinking of the left side of the blue line and the right side of the blue line. So if this side is true, then this side over here is false. And then where should I shade? True side. So our double shade is pretty big this time. Okay. And I can double check my answer on Desmos. So 5x plus y is less than 2. Yep. And then y is greater than 2x minus 5. Oh, greater than or equal to. Yep. Mm-hmm. Okay. All right, the next one has 3. Whew. Okay, we're going to need more colors. All right, where should I start the first one? 6. And where do I go from there? Up 1, right 2. Up 1, right 2. Then I ran out of space, so I'm going to do the opposite. Down 1, left 2. Down 1, left 2. Down 1, left 2. Is this line dotted or solid? Dotted. Okay. And what do you guys want to plug in? 0, 0? So 0, 0 is right here. So we're going to do 0 for x and 0 for y. 0 is less than 1/2 times 0 plus 6. So 1/2, we can just type in 1 divided by 2. There's 1/2 times 0 plus 6. It's just 6. Is 0 less than 6? True. So the bottom side of the line is true. Over here where the point is, that's true. That means the top side of the line is false. So where should we shade? Shade the bottom side of the line, this huge area. This whole thing. Shade it, shade it, shade it. Okay. Now for the second equation, what does that mean? It's always 5. The what? Say that again? The x coordinate is always 5. So I'm just going to write down some points. So I've got like the point 5, 0. What's another point? You don't have to. What's another point I have? 5, 2. What's another point I have? 5, 8. How about some negatives? What's another point I have? 5, negative 6. Okay, so I'm going to draw all these points. So I got 5, 0. I've got 5, 2, 5, 8, and 5, negative 6. And I'm going to connect those points with a straight line. Is it solid or dotted? Solid. Okay.
Oh, dang it.
And do we want to use 0, 0, or do we want to use a different point? 0, 0. So 0, 0 is over here. It's on the left side of the blue line. So 0 for x, 0 for y. If I look over here, is there a place to plug in the y value? No, there's only a place to plug in the x value. So that's the only value I'm going to plug in, is just something for x. So I put the 0 in for x and I put nothing in for y. Is it true that 0 is less than 5? 0 is less than 5. That is true, so I'm going to say that's true. So the left side of the blue line is true. That means the right side of the blue line is false. And so then where do I shade for the blue line? The true side to the left. Okay, so I'm keeping track of what my double shade is. It's like this whole big area right here. But now I have a third portion of the graph I'm going to do, so I need another color. And this one says y and negative 3. So what does that tell me? The y coordinate is going to be negative 3 for every single point. So I'm going to have the point 0, negative 3. What's another point I'm going to have? Negative 6, negative 3. What's another point I'm going to have? 1, negative 3. What's another point I'm going to have? 2, negative 3. Okay, let's graph these points. So we have 0, negative 3. We have negative 6, negative 3. We have 1, negative 3. We have 2, negative 3. Okay, so when we connect those points, do we have a dotted line or a solid line? A dotted line. Okay. There's our dotted line. Do you guys want to use the point 0, 0 or use a different point? 0, 0. Okay, so 0, 0 is right here in the middle. If I use 0, 0, I'm using 0 for x and 0 for y. There is no x value to plug in. There's only a y value to plug in. So I'm only going to plug in 0 for y. 0 is greater than negative 3. Is that true or false? True. So this part right here, this point is true. That is true above the pink line. That means that below the pink line is false. So I'm going to shade above the pink line. And then my answer is where I can see pink and blue and pencil all at the same time. Pink and blue and pencil all at the same time. So where am I seeing all of those colors? Kind of like in the middle, where 0, 0 is, right? Because 0, 0 is true for all of them. So it's this corner, right? This corner is like the boundary, and it goes along here, and it goes along here, and then it goes along this dotted line, and along the blue line, and then this whole part right in the middle. So the hardest part about doing multiple graphs is you just have to keep track of what you're shading. That's the hardest part, okay? So let's check this one on Desmos. Let's make sure we got it. So y is less than 1/2 x plus 6, okay? X is less than or equal to 5. Y is greater than negative 3. Yeah, so there you can see there's our kind of shape right there that we were getting. Okay, how do your brains feel about graphing these? It's a lot of work, yeah. So this is our 4th day of graphing. So how do we feel about graphing lines? Can we graph lines? We can get the y alone if we need to. We can graph our y-intercepts and our slopes. Can we do shading accurately? Dotted lines, solid lines, shading? We can do that accurately? Okay, and now we know that we can use Desmos to kind of check our answers as we go. Okay, all right, so I'm going to hand out the assignment.